The question number 26 is two capacitors of capacitance 2 microfarad and 4 microfarads are joined in series. The outer plates of the first capacitor is at 600 volt and the outer plate of the second capacitor is as shown in the figure. Now, what is the potential of the inner plate of each capacitor? So we want to find out potential of this point. Let's say it's B. Now, as it is 600 potential and this is 0, so charge will flow from here. They are in series. The same charge will flow from here. Now, how much charge will flow? So that we can use KVL. So 600 is equal to Q divided by C1, which is equal to 2 into 10 to the power minus 6 plus Q divided by C2, which is 4 into 10 to the power minus 6. And you get the charge is equal to 800 microcoulomb. Now, what is the potential of this point? This is at 0. So V minus 0 is equal to charge here, which is 800 into 10 to the power minus 6 divided by capacity, which is 4 into 10 to the power minus 6. So the value is 200 volt. So potential of this point is 200 volt. Therefore, the correct option is the third one. Question number 27. For the circuit as shown in the figure, the charge on the capacitor in steady state. So when the steady state comes, this capacitor fully get charged either from this or this direction, and the current is still continuing in this direction. So what is the current flowing through this branch? So current is equal to the EMF, which is E divided by R plus R. So that is E by 2R. Now what is the potential difference across these points? The potential across, let's say the point A and B, the potential drop across this point A and B will be equal to the current, which is equal to E by 2R multiplied by the resistance, which is equal to E by 2. Now, if it is a steady state, then no current flows through this, no potential drop here. So whatever the potential drop, that is across 2. And the charge on this capacitor is Q is equal to C into V, which is equal to 2C, and potential drop is equal to E by 2. So this comes to be E into C. So correct option is the third one. The range of galvanometer becomes V when 40 ohm resistance is connected in series. Its range gets doubled when 800 ohm resistance is connected in series. The resistance of the galvanometer would be. Now see, this was a galvanometer with certain resistance say G, and he says then when you connect with this one a resistance of 40 ohm, then there will be certain current, say IG or I current is flowing, then V is the potential drop. So what is the equation? V is equal to IG plus 40 into I. And in the second case, he says that when this galvanometer is connected to 800 ohm resistance, then potential drop across this is 2V because the reading is doubled. So 2V will be equal to the same current is flowing. So I into G plus 800 into I. So we divide the equation. So 2 is equal to G plus 800 divided by G plus 40. So cross multiply. So 2G plus 80 is equal to G plus 800. So on this side and bring on right side. So G comes to be 720 ohm. So the correct option is option number 2 to this question. Question number 29 is magnetic field induction at the center of the circular loop of radius A carrying current I is as shown in the figure. Now dear students, we consider this is to be made of uniform area of cross section and homogeneous material. So when it comes, the current get distributed into this one and resistance is proportional to length. So if the current from this is I, then current in this section would be a different current. If the current in this section is I1, then current in this section is I2. Now, the current I2 will be less and I1 will be the more current. Now, if it is homogeneous, the potential is uniform, so current I2 will be less than I1. But its contribution at this point will be more. As it contributes more, then the magnetic field because of this one is equal to mu naught I1 divided by 2, whatever the resistance and whatever the angle, theta, this angle. And the contribution of magnetic field because of the second is mu naught I2 divided by 2R, and this would be angle theta 2 in the radians. This angle is taken in degrees. Now V1 is equal to V2 always, but the directions are opposite. Because of this one, the magnetic field will come out, and because of this, the magnetic field is inwards, and both magnetic field current cancel out. Net magnetic field will be 0 at the center. So answer to this question is 4. The question number 30 is 3 inductor, each of inductance 12 Henry and resistance of 3 ohm are connected with a battery of EMF 9 volt as shown in the figure. The total magnetic energy stored in the inductor would be in steady state. Now see, when it is a steady state, then there is no barrier by these inductors. So the circuit current I will be equal to the EMF, which is 9 volt divided by resistance. So 3 ampere current will be flowing in the circuit. Now these three inductors are connected in parallel. The total equivalent inductance will be equal to 4 Henry. And the energy stored, you know the formula is equal to 1 by 2 into total inductor into the current square. So this is 1 by 2 into 4 and the current is 3. So this would be 18 joule. The correct option is